So a hyperbola is one of the shapes you're going to be probably least familiar with. But if you look at this like lampshade, y'all know when you turn on a lamp and there's like part of the light goes up and part of the light goes down from the lampshade? Yeah. The shape that it makes of the light on the wall is a hyperbola. So this is a shape that appears in real life, and so we do need to study it when we study conic sections. The hyperbola has branches, meaning if you just gave me the bottom part of the lamp, that is not a hyperbola. A hyperbola is both a bottom branch or a top branch, or a left branch and a right branch. Okay, so we're going to refer to them that way. Now, just like with the ellipse, there is a lot of vocabulary involved with the hyperbola, so let's follow along. The focus or the foci is the two fixed points, F1 and F2, from which each branch of the hyperbola is equidistant. This time we're doing the difference instead of the sum. The foci this time are not inside of the shape itself, in between the lines. The foci are going to be inside the branches themselves. They're like a focal point inside each branch. So that is the focus. The vertices are the points where the line that goes through the foci intersects with the hyperbola. This feels like the turning point of the hyperbola. That is the vertices. We no longer have a major and minor axis. Those were vocabulary for the ellipse. But in the same way as keeping all of the points together, we have a transverse axis. The transverse axis is the line segment that joins the vertices. If you notice, if I did actually extend that transverse axis, it would go through the foci as well. It just doesn't. This is the, I'm gonna run out of space here. Transverse axis. Just like the ellipse, there is a center of this shape. The center of the hyperbola, don't overthink it, is right in the center. Again, notice that my transverse axis, if it extended to the foci, would go through all 5 points just like it does with the ellipse. But what this shape has that the other shapes do not are asymptotes. The asymptotes of a hyperbola is a pair of intersecting straight lines that pass through the center of the hyperbola, that the two branches of the, that pass through the center, and that the two branches of the graph of the hyperbola approach as x or y increases or decreases without bound. It's a lot of words to say that these asymptotes are going to like crisscross across the shape. So there's one of the asymptotes. I'm using yellow. Can you see it?
Yes.
I'll zoom in a second.
It goes through the center, right?
Do we see them? It goes through the center and like gets very close to the edges of both branches. Do we see that now? Yeah. I guess I should label the center here. Now there's a few unnamed vocabulary words in this problem that we are also going to label on here. There are minor vertices. They touch nothing. So they're not official vocabulary words. They're a Miss Quigley vocabulary word. If we put a dot in purple, here and here, it's too low. And this color is purple on purpose because it comes from the B value out of A, B, and C in the formula. But what I wanted you to notice here, and the reason we put it down, is do you notice that there kind of like is a box that is created? If you go through the vertex, this invisible purple point, the other vertex, and the other invisible purple point, do you see that box? If I had drawn my graph better, my example better, the asymptotes should go corner to corner on that box. This one is pretty good. vertices, but they're not actually a vertex because they don't touch the actual branches. But to keep that concept the same from before, these are as acting like my major vertices, and these are my minor. They're not called that, but it's okay to categorize them in your brain that way. So when we are graphing hyperbolas, we're going to want to make this box, the black box that I put in there from the purple and the blue points, because it will allow me to draw my asymptotes very easily, because it goes corner to corner. Okay, if we look at the formulas here, we have a lot of the same sort of ideas from the ellipse to the hyperbola. In fact, the center is still at h comma k, and the a value is still bigger than the b value. Notice, a value bigger than b value. What do you notice, though, that's a main difference from the ellipse equation to the hyperbola? The x and y, something with them. What do we notice about them? They flip. What does not flip this time? The a and the b are always in that order. A is always first, b is always second. The x and the y might switch. What else do you notice maybe that I'm like pointing at? That there's a minus. For the ellipse, when you were making the shape, it's like you put two branches together. We added them together to close the shape. So for the hyperbola, since we're subtracting them, it makes two separate branches that go opposite directions. So if we add together, it's ellipse. If we subtract, it's hyperbola. So let's color code some of these things on this so we just have a good idea again of where everything went. So we have the foci that are going to be inside the branches for either the horizontal or vertical transverse axis. We will have the center that's in the center. For both of these, that's the origin. Nice. We have the vertexes, the actual vertexes that are blue. But we have a b value that we hadn't used. The b value was purple for the ellipse, so it's purple for the hyperbola, and it goes on the opposite axes, not touching the graph at all. And if I draw in my little box that connects the purples and the blues, we will notice that our asymptotes, when we draw those in, should go corner to corner of that box. Corner to corner of that box. One last thing I want to point out on this page before we start using the formulas, and again, this is a formula chart for you. We're going to go back and look, is that the formula for focal length is different. What do you notice about this formula for focal length? How is it different from the other one?
It's plus.
It's plus. So guess what?
It's Pythagorean.
This one is Pythagorean theorem. So when you do this focal length formula for the hyperbola, it is Pythagorean theorem. It was not Pythagorean theorem for the ellipse, but it is for the hyperbola. Shall we go try some? Again, this next few examples are going to feel like the examples from the ellipse. So these are going to feel like the examples we did with the ellipse, which means if you had a question mark about some part of that lesson, maybe I will answer it here. When we're graphing hyperbolas, we're still going to need to find the center, the a and the b first, and then find c. But the a and the b are going to allow me to find the little box that helps me draw the asymptotes. Follow along with me. For this one right here, what is the center of this hyperbola? Very good. Since there's no numbers next to x and y that are added and subtracted, the center is back at 0, 0, the origin. We now need to find a, b, and c. This is exactly what we did for the ellipse. But remember, in these formulas, the a is always first. So what is the a value here?
35.
Close.
X.
It's 5. Why is it 5, not 25?
The square root.
Square root, very good. So what's b? 4, nice. And how do we find c? A squared plus b squared equals c squared. So if we solve for c, that means we're square rooting both sides. So this is going to be 25 plus 16. 25 plus 16 is 41, and we can't take the square root of 41, so we leave it like that. Okay, we have A, we have B, we have C. We now found the focus, this, vertices, and the asymptotes. All right. To find the focus, what you are going to do is you're going to take the center points and you're going to leave yourself space so that you can add and subtract this number to either the first coordinate point or the second. Now, since this has an a value that is underneath x, is this hyperbola going to be side to side or up and down? If it's underneath the x. Side to side, which means we have a horizontal transverse axis. My branches should open side to side. So we know that my foci should also go side to side. That means that I am adding the focal length of C to the x value in that center. So my foci would be found at negative square root 41 comma 0 and positive square root 41 comma 0. Since I know we're going to be graphing this later, I went ahead and figured out what the negative square root of 41 is, and that's approximately negative 6.4, and this would be approximately 6.4. Okay, for the actual answer, we want it in exact terms, but to actually graph it, we probably want the coordinate point, or the decimal approximation, sorry. Okay, we find the vertices. The major vertices come from blue. Blue is A, which means in the same way we're going to start with the center, which was 0, 0, and leave ourselves space. We're going to add and subtract the A term from one of these coordinate points to create the point for the vertices. But again, since this is a horizontal transverse axis, since the x went first, we're going to add and subtract the A value, which was 5, to the x term for horizontal. Which means that my vertices are going to be at negative 5 comma 0 and at 5 comma 0.
Why is it plus 1?
That's the formula.
Oh, yeah.
That because we're taking that many steps to the left and to the right, so we have to subtract it and add it. The last thing we need here is the formula of the asymptotes. This is one you might want to flip back for the formula itself. For a horizontal transverse axis, what does your formula chart say is the formula for the asymptotes? Should be y minus k, k was 0, equal to plus or minus, what does it say after that? B over A. That's 4 over 5. B over A times x minus 0. Now, of course, I can't help myself here. The minus zeros are super boring, so we can actually condense this down to y equal to plus or minus 4 over 5 times x. But besides being able to tell me what the asymptotes is, you don't need it for graphing because we're going to use my shortcut with the box. Here's what I mean. Where was our center again?
0, 0.
0, 0. So I start with that. I'm also going to plot my foci, which are at approximately negative 6.4 and positive 6.4, comma 0. So those are x-intercepts. I also know that my foci, we just did that. My vertexes are at negative 5, 0 and 5, 0. But here's a connection I want you to make. How many steps away from the center is these blue dots? 5. Where did the 5 come from in this problem? A. What do you think I should do with B then? If 5 is how much I go side to side?
4. It's going to go 4 up.
4 up and down. Okay, cool. So we're going to do 4 up and down. These are those purple dots that I told you are not real vocabulary words for this particular shape. They help us out though, because now I can make my box between the purple and the blue dots. And if I make my little light invisible box between these, it's going to be like this. And I now know how to draw my asymptotes. My asymptotes come from going corner to corner on these shapes. So if I go corner through the center to corner, that's one of the asymptotes. You cannot see that, can you? I'm trying to make a yellow that's easier to see. Is that better? Okay, there's one of the yellows. And if we come from the other one, going corner through the center to corner, we have our other asymptote. If you're thinking to yourself, where's the actual hyperbola? Great question. You're going to go from vertex and then get close to the branches, meaning I'm going to go from the vertex and get close to the branch here, from the vertex get close to the asymptote here with the branch. Then I go to the other side and graph it in. Is this still a horizontal transverse axis? Okay, good. That's what we wanted. For the middle one, something's wrong. What's wrong? We divide everything by 36 to make this happen, so I'm just going to go, wow, 36. So this is 9 over 36, which is 4, and 4 over 36, which is 9, equal to 1. Is that what we got? 9 over 36. If you do it backwards, what's 36 divided by 9? 4. Put it in the denominator. And then for the other one, what's 36 divided by 4? Put it in the denominator. If you do 9 over 36, it'll give you 0.25 or 1/4. Okay, question for you. In this equation, what letter came first?
Y.
Y. So is this going to be a horizontal or vertical transverse axis? Vertical, nice. We keep that in mind. This is going to be a vertical transverse axis. Either way, though, what's the A value?
4.
Wait, I just drew this the wrong direction. The A value is 2. Very good. The A does not move in a hyperbola. In an ellipse, it was the largest number no matter where it was. In a hyperbola, it does not move. It's first. What's the B value? 3. My transverse axis is still 4. The C value I find by doing Pythagorean theorem, which is 4 plus 9. 4 plus 9 is 13, so C is square root 13, which we can't do the square root of 13 without making an irrational number, so we'll leave it as square root 13. Now we go through the same steps. This time when we find the foci, we start from the center, which is still 0, 0. But this time, since I have a vertical transverse axis, am I going to add that focal length C to the X or to the Y?
The Y.
The Y. So this time I'm going to add and subtract square root 13 to the Y, which means my foci are going to be at 0, negative square root 13 and at 0, square root 13. Now again, square root 13 is how we would answer this, but if we're actually graphing it, this is approximately negative 3.6 and this is approximately 3.6. Next up, we will find the vertices. We start with the center, which is 0, 0, and we are adding the number 2, because that's A. Are we adding that to the X number or the Y number?
Y.
This is a vertical transverse axis, so we're adding it to the Y. Very good. So the vertices are going to be at 0, negative 2 and at 0, 2. The only thing that changes in the formula for the asymptotes when we switch from a horizontal transverse axis to a vertical transverse axis is the fraction. This time it tells me on my formula chart to do A over B instead of B over A. So my asymptotes are at y minus 0 equal to plus or minus B, which was 3, over A, which is 2. Nope, I did that backwards. Hello? A over B, Miss Quigley. 2 over 3, x minus 0.
So it's still.
So if I'm looking at the formula chart and for the vertical transverse axis, it says A over B. Horizontal, it says B over A. But I can't help myself. The zeros are boring, so this is y equal to plus or minus 2/3 x. I know I could use it as the slope of up 2 over 3. But I also know that that gives me the box corners to be able to draw this better. So we start with what we know. We know the center is at 0, 0. We know the foci are at 0, negative 3.6-ish and 3.6-ish. Yeah, 3.6-ish. Do your best. We know our vertices are at 0, 2 and 0, negative 2. Notice all 5 of those lines are on the same, all 5 of those points are on the same line, my transverse axis. I then know that my B value will help me find the side-to-side distance from the center. My B value was 3, so I'm going to go 3 to the left and 3 to the right of my center so that I have the box and I can draw my asymptotes. If I draw my asymptotes going corner to corner of this box, oof, that's not straight. Let me try that again. Remember this time that we should be opening up and down with a vertical transverse axis. So we play connect the dots with the blue, and there's nothing we really connect. We just get close to but never touch the asymptotes, branching out both up and down. We're bracing for it, but where is the center of this hyperbola? 2, 3. Okay, so when we're doing this problem, we're going to start all of our foci and vertices and asymptotes with actual numbers instead of just 0, 0. But we need to find out A, B, and C. What is A? 4. What is B? 3. And how do we find C? Yeah, Pythagorean theorem. So 16 plus 9, which is 25. What's the square root of 25?
5.
Nice. Okay, we have an actual cute number here. No offense, other numbers. Is this graph going to have a vertical transverse axis or a horizontal transverse axis?
Vertical.
Okay, now we've heard both. Which one is
Oh,
it?
wait, horizontal because the X is first.
Very good. Horizontal because the x went first. Since there's an x in above the a squared, that means this is going to be a horizontal transverse axis. So all things that should be on that transverse axis, the vertices and the focus, we should be adding those numbers to the x value, not the y value. So if we go to do the focus, the foci are found by taking the center, which is 2, 3, and we are going to add and subtract the focus number 5 to the x value because it's a horizontal transverse axis. That means that my foci are at 2 minus 5, which is negative 3, comma 3. And at 2 plus 5, 7, comma 3. The vertices, again, we start with our work giving the center 2, comma 3, and we are adding and subtracting the a value to the x because the vertices should also be on that horizontal transverse axis. So we are going to add and subtract a, which is 4. So my vertices are at 2 minus 4, which is negative 2, comma 3, and then 2 plus 4, which is 6, comma 3. All right, let's write the coordinates or the equation for the asymptotes. If we're following the formula, it should be y minus k. What was k again? One of the center. Is it the first coordinate or second coordinate? Nice. So that means that it is 3 equal to plus or minus. This one wants b over a. What was b?
3.
3 over a, which is 4, multiplied by x minus h. H was 2. I'm not going to make us reduce this one because it turns into a lot of algebra we just straight up don't have room for, but if you needed to do this on your own, you would distribute negative 3 over 4, solve for y, and then distribute positive 3 over 4, solve for y separately. We just don't have the space, nor do we really need it because we're going to use my box to find the asymptotes. Okay, we graph. What was the center? 2, comma 3. So here's the center now. The foci we found to be at negative 3, comma 3 and at 7, comma 3. And that visually makes sense because it looks like the orange is right in the middle of the pink. That's good. Our vertexes are at negative 2, comma 3 and at 5, comma 3. Is that right? Is that wrong? Should be 6. It should be 6. I can't read my own handwriting. LOL. That makes sense because now they're centered at the center and they're all on the same line. How do I get those purple dots again?
It's going to be the y,
The B. And since the A value told me to go side to side, the B value is going to tell me to do what?
up and down.
Up and down. From the center, we are going up 3 and down 3. That gives me the dimensions of my little box. So that I can then take my asymptotes and draw them from corner to corner of the boxes. And then go from the vertex close to the branches. With the ellipse, after we've spent a second giving the equation and wanting the graph, what if I don't give you the equation, but I give you pieces of the graph and want the equation? We're going to think the same way we did for the ellipse, and we're going to work backwards. This question tells us that we have a foci, foci at 0, negative 3 and 0, 3. And we have vertices at 0, negative 2 and 2. With the ellipse, to help figure out all of the pieces of information, we need to do a little bitty sketch so we can see what's happening here. And if I were just to sketch these onto a coordinate plane, I would see that the foci are like here and here, and that the vertices are like here and here. So we learned 2 things from just looking at that little sketch. The first thing we learn is that this hyperbola has what kind of transverse axis? Vertical or horizontal? Vertical, because all of these things are in a vertical line. Very cool. So let's write that down just for ourselves. We learned that it was a vertical transverse axis. We also learned where the center is. Where's the center of this hyperbola? 0, 0, because it needs to be right in the middle of these two things. So I know now that the center is at 0, 0. To be able to write the equation of the hyperbola, all we need is the center and the A and the B. From what I already know, I know that C is 3 and I know that A is 2. How do I know this?
It tells you.
Where?
You can do the -3 and the 3.
And remember, foci comes from your focal length, which was 3. So that's C. And then the vertex is 2 steps away from the center, so A is 2. We just need to know B. But how can we find B? What's the relationship between A, B, and C for a hyperbola? It's everybody's favorite geometrical theorem.
Oh, it's 3 equals.
So it's
plus
3 equal to the square root of 2 squared plus B squared. It's Pythagorean theorem. So if I square both sides, I get 9 equal to 4 plus B squared. Subtract 4 from both sides, I get 5 equal to B squared. So what is B equal to? Well,
25.
no, other direction. You made it too big. How about square root 5? That's what you meant to say, right?
Yeah.
Okay. So that means B is square root 5. That is all we need to write the equation of the hyperbola. You guys told me vertical transverse axis, so what letter should go first? Y or X? Y. So this is y minus k, 0, over a squared minus x minus h squared over b squared equal to 1. But let's clean that up. Y minus 0 and x minus 0, we don't need to write that, so we can just write this as y squared over 4 minus x squared over 5 equal to 1. So we work backwards with what we were given to make conclusions on what type of vertical or horizontal transverse axis we have and the center, and then use that information to find the missing B piece.
Wait, where did you get C from?
Great question. Where did I get C from? The C has everything to do with the foci. How far away from the center is the focal point? 3. So C is 3.
So it's not negative?
No, because it's distance. Distance is never negative. I know that it's down 3, but the distance itself is 3. We ready to complete the square? So just like with the ellipse and with the circle, we can take a general form of a hyperbola, complete the square on both the x's and y's, and solve for the standard form. Think back to what we did with the ellipse. What should I do first? Say again? Separate the x's and the y's. I like it. All right, so for this one, we're going to have 4x squared minus 24x plus mystery number minus 25y squared plus 250y plus mystery box equal to positive 489 plus mystery box plus mystery box. Does that setup sound like something we've done before? Okay. Now this was the step with ellipses that might have been confusing with me not explaining it. To complete the square, the term in front of the x squared should be 1, the number in front of it, the coefficient. So for all of the x's, what should I divide all of the x terms by? 4. So my next line of this equation would be 4 times x squared minus 6x plus mystery box. What should I divide all of the y's by? negative 25. So if I divide by negative 25, I will end up with positive y squared, negative 10y, and their mystery box. But of course, since I factored it out on the left side, I'm going to have to multiply the mystery box by 4 for x and the mystery box by negative 25 for y, because that's what I factored out.
Is that a zero or the circle?
That is a circle. That's a mystery box. You're right. It doesn't look much bigger than my... Is that better? Okay. Whew. We're set up finally. We can complete the square. What's the tiny little formula for completing the square? B over 2 squared. Very good. And the b is the term next to the regular letter x. So this will be negative 6 over 2 squared, which is negative 3 squared, which is 9. That's what will go here. 9 in the box. Then I do negative 10 over 2 squared, which is negative 5 squared, which is 25. 25 goes in the box. It's a circle. You get it. And 25 in the circle. It looks horrendous, but it will clean up in one step. Everything drops down. This is 4 times x minus 3 squared minus 25 times y minus 5 squared equal to everything from the other side. So in your calculator right now, you will do 489 plus 4 times 9 plus negative 25 times 25. You're doing everything on this side. What do y'all get? Should get negative 100. I think I went faster.
Yeah.
Okay. This is close, but it's not good. Why is this no good? It's not equal to 1. So what am I dividing everything by?
Negative 100.
Negative 100. I'm going to do it like this. Well, pow. Divided by negative 100. So 4 over negative 100 is x minus 3 squared and then negative 25 on the bottom. Negative 25 over negative 100. That's going to be y minus 5 squared over positive 4, because negative over negative is positive. Negative 100 over negative 100 is 1. Now, I still don't like this. Why do you think I don't like this for a hyperbola?
Negative.
I got a negative 25 right here. That's weird. And also, look at what's in between these two equations. It should have a minus. So we just have to rearrange this. The negative term is the x term. The positive term is the y term. So we just need to reorder it. So it's y minus 5 squared over 4 coming first. And then minus x minus 3 squared over 25 equal to 1. Now it looks like a hyperbola. So now the minus is in the center, and there's no negative denominator. That's weird.
So you just, okay.
I just reordered them so that it is in standard form.